Question 1 here was very tricky. It got quite a lot of my time just to think about the 30% here, guys. This is important. When there is a uniform distribution question, is cutting something. If you cut 1 centimeter from the left, it might give the same result as cutting 1 centimeter from the right. So that is why instead of considering uniform from 0 to 42, reduce it to 0 to 21. You gotta visualize this one first. So this area here is a quarter of the other one, right? Just following that equation. The technique, just to come up with how you deal with the continuity correction, do you add 0.5 or minus 0.5? So the result should be such that you get a little more area. So you gotta move it to the right a bit by 0.5. Because remember, in Poisson there are 3 assumptions, like 3 criteria, so that you can model something as Poisson distribution. The constant rate of occurrence, the independent events here, but we gotta put in context when we answer. And the third one is the capital Fx is a continuous function, where the PDF might not have to be. This is usually true in almost all papers. If you have the diagram or the graph, try make use of it. Try make some sense from it, right? Otherwise, they won't give it to you. Hi, it's me, Base. Today I'm going to do another walkthrough on an unseen paper. Now this time it is IAL S2, October 2024. You can use chapters in the description to jump to any question you want. After I hit the timer, there'll be no cuts, no edits. Are you ready? So I have started the timer. Let's get started. Note that I have a formula sheet right here with me. Okay, number 1. During an annual beach clean, the people doing the clean are asked to conduct a little survey at a particular beach clean. Litter was found at a rate of 4 items per square meter. So when you see the word rate, right, rate of something per something, that is indicating a Poisson distribution, right? So number 1 here, A, find the probability that a randomly selected area of 2 square meters on this beach, exactly 5 items of litter were found, right? So let's bring up the Poisson formula there in S2. So it's quite towards the end after, yeah, here we go. Poisson distribution. So we have here X follow a Poisson distribution, lambda, right? But lambda needs to be changed first because it's given as 4 per square meter. So it's 4 per 1, yeah, 4 per square meter. That means per 2 square meters, it will be 8 per 2 square meters, right? I'm just writing there. So we are using lambda equals 8 instead, all right? So that's going to be X modeled as Poisson, lambda being 8. And we want exactly 5 items, and then we find the probability of that. So I'm just going to use here Px equals 8 exactly. It's going to be equal to 8 to the minus, yeah, we're taking this formula here, minus lambda, lambda being 8. And then 8 to the power of x. Wait, hang on. It's, sorry, it's exactly 5. So this is 5, not 8. Let me try to do that. Okay. So this is 5. And then let's look at the formula again. To the x, because I don't remember this formula actually. So hang on, to the 5, yeah. And then, well, that's e to the minus 8, and then lambda, which is 8, to the 5, which is x, over 5 factorial. Okay, and then we're just going to calculate the probability of that. Calculator. Okay, so fraction, e was e, hang on, e to the power of minus 8, then bring it down, hang on, multiply 8 to the 5, and then divided by 5, whereas factorial in here, 5 factorial, okay, it's that. Okay, so this is going to be 0.091, so how many significant figures? I'm just going to give it 3 significant figures, so that would be 0.0916, all right, yeah? So that would be number 1 there, okay? Okay, B, of the litter found on the beach, 30% of the items were face masks. Okay, so it's like, maybe during the pandemic or something. Find the probability that in a randomly selected area of 5 square meters, so now this time it's 5, it's not 2, on this beach, more than 4 face masks were found. Okay, so we are, okay, let me think a bit on that. Right. Okay. So it's like using Poisson as a binomial this time. Yeah? Because in a given area, you have a Poisson distribution to find litter. Litter is just garbage, basically. Right? And then in the 30% of the garbage found will be face mask. All right? So in a randomly selected area of 5 square meters, there'll be more than 4 face masks. So more than 4 face masks, that means we're gonna have to take the litter found. So in the litter found, hang on, let me try think a bit about that, okay? This is a little confusing. Okay, hang on. More than 4. Okay, so I'm gonna do this first. So we need to find, okay, so we need to find px greater. Yeah, finding a face mask more than 4 is only possible when the number of items of litter are greater than 4, right? So I'm going to do here greater than 5 first, greater or equal 5, because this is discrete, so you're going to use that. And we're going to get this from the Poisson distribution, all right? So that will be 1 minus px less than or equal 4, okay? And this will be lambda equals, because this is 5 square meters, so lambda will be equal to, so we multiply 5 divided by 2, okay? Wait, no. Per square meter is already 4, so lambda will be 5 times 4, which is 20, yeah? Okay, so we're gonna have to find the probability of that first. So we're gonna use a table and using lambda of 20, yeah? Yeah, I think, yeah. So let's see. Wait, I don't think lambda of 20 is in here. Yeah, we only have 10. Hang on, I'm in trouble. So 4 items per square meter. This is 5 square meters. Okay, here's my thing. Because we can't really use Poisson of greater than 20, and it doesn't say approximation. Sorry about the long silence there. It's still Poisson, but we need to do something. So I'm not sure if this is gonna be right, but I'll maybe use some video editing, not the cut, but I'm gonna edit the text underneath here if there's anything. But I'm thinking that because we are changing the lambda to 20, but this is for all types of litter. But lambda for face mask would just be 20 times 0.3. So that would be 6, right? So here we're going to do y, yeah? So instead of x, we're going to do y, PO, and then lambda being 6 instead, okay? And this is for 5 meters squared already, so we're going to use 6 here. And that would just be P of more than 4, which is the same as P more than or greater than 5. So that would be 1 minus x less than or equal 4, because you've got to make it an equal sign in order to find in the table. All right, so just got to be careful with that. Shrink down a bit. Okay. So let's open the table there. So this is going to be 1 minus. So lambda being 6 right here, x less than 4. So that's this one right here, yeah? 0.2851. Okay, so I'm going to do 1 minus 0.2851. And that will be the answer there. So that's 0.7149. Okay, that's kind of the best idea that I can come up with. I'm sorry about the long silence. I have taken quite long there. All right, so C. Using a suitable approximation, find the probability that in a randomly selected area of 20 square meters on this beach, less than 60 items of litter were found that were not face mask. Okay. Okay, in a randomly selected area of 2 square meters. So lambda will be now equal to 20 times 4. That's beyond what the table can offer to us, right? Because lambda is just up to 10. So we're going to use Poisson. So instead of XPO 80, we're going to approximate that to, let's say a Z, maybe. No, not a Z. Maybe a Y, yeah. Normal distribution, right? Because that's the only way we can approximate. We don't have anything better than normal. And that would be 80, and variance would be 80, okay? Less than 60 items, all right, were found that were not face mask. So, again, this is face mask. So we're gonna have to multiply. Okay, this is all again. So the actual lambda would be 80 multiply 0.3, right? So that would be 24. So we're gonna use 24 instead here. I'm just gonna take my chances. Okay, but this is face mask. Okay, so if less than 60 items were found to be not face mask, so we will need to find the probability. Hang on. No, we need to change this to a 0.7. So it's going to be the opposite. So this is lambda not face mask would be equal to the opposite, 0.7 times 80. So that would be 56. Yeah, that took me a while. Okay, that's a bit tricky, guys. Okay. Okay, we're going to use that instead. So this is the distribution for picking a non-face mask item. Yeah. Okay, now it's easy. We figured it out. So suitable approximation there. So if we draw a bell curve roughly, just to get an idea of where this can be, right? So that's a bell curve there. The mean is about 56. And we needed less than 60 items, 60. So 60 is around here, yeah? But because we need to do the continuity correction, don't forget, we need to, so my technique here about the continuity correction is that, so you want the area, right? You want the probability of X less than 60 item. You got to be careful. This is saying less than 60. So we need to change that to P of X less than equal 59 first. That has to be changed to 59 instead. Now, once you have this, and then you get, you think a bit about, okay, this is the area. What area am I looking at? It's the area to the left of that. The technique, just to come up with how you deal with the continuity correction, do you add 0.5 or minus 0.5? So the result should be such that you get a little more area. So you got to move it to the right a bit by 0.5. That means instead of doing a 59 there for the Poisson, you're gonna have to do P of Y here, because Y stands for the normal distribution. We model Y as a normal distribution, so it gotta be less than 59.5. Okay, and then we do the Z value and just find the probability there. Okay, so Z value for that is 59.5 minus square root of the variance, the mean, minus the mean first, and then over standard deviation, which is the square root of 56 here. Okay, so that would be the Z value there. I'm just going to plug in the calculator here. So 59.5 minus 56 divided by square root of 56. That gives me 0.46771. Okay, and then I'm going to open up the table to find the probability. And that would be the, that would have to be the, the bell curve probability. Where's that? Okay, it's here. So 0.4677, 0.4. I'm just going to give it 0.47, right, guys? So P of Z less than 0.47 would be equals to, so I'm going to make 0.681. Just 3 decimal places there, just rounding a bit up because we use a rounded Z value there. Okay, that's done. Phew, that was the first question. That was already something, right? Okay, number 2. I hope it gets easier towards the end. Multiple choice test consists of 2 questions, each having 5 responses, only one of which is correct. Each correct answer gains 4 marks, but each incorrect answer loses 1 mark. Sam answers all 25 questions by choosing at random 1 response for each question. Okay. Let X be the number of correct answer that Sam achieves. Find the distribution of X. Okay. All right. Distribution of X. Ooh, that's the probability. Distribution in this case would mean how do we model X, right? So do we model it as Poisson, binomial, or normal? This is discrete because you can't have 4.5 questions, right, to be correct. And because each question have a fixed probability of getting it correct, which is, if you randomly guess a multiple choice question's answer, it's going to be about, in this case, because there are 5 choices, so you're going to have 20% chance of getting it right. So 20% chance is 0.2. That means we're going to model this as, that's A, binomial. And there are 25 questions, so that's an N. And the probability of success, which is the number of correct answer there, X, yeah? Each one being 0.2. All right, so that's it, binomial. That's A. B, let M be the number of marks that Sam achieves. State the distribution of M in terms of X. So M here will be equal. If X represents the number of correct answers, so we have to multiply X by 4 because each correct answer gains 4 marks. So 4X there. But then he would lose 1 mark for each wrong answer. So we got to do minus, right? Because M is the number of total marks. Minus, but what is the number of wrong answers? Well, it's just total number of questions, which is 25, subtracted by the number of questions that he got right, which is x, right? Because if you got x right, and 25 minus x would be the wrong questions. And we gotta multiply that by 1 because, yeah, this is already a minus 1 here in front, right? It's the same thing. So if we simplify that, we get 4x plus x, yeah, minus 25. All right, so m would be 5x minus 25. That would be it, okay? That would be the distribution of m in terms of x, I think. So x can be found by the binomial. We plug it in. So this is just that. Yeah, I think this is it. Sorry, that's bi here, and this is ii. Hence show clearly that the number of marks that Sam is expected to achieve is 0. So this is expected score, okay? The number of marks that Sam is expected to achieve, okay? So we got to do expected value here, but let's find expected value for the x first, and then we can plug it in here, right? So expected value for the distribution x would be just np. Okay, so that's 25 times 0.2, which is 10. No, that's 5, sorry. Yeah, just do the mental math there. And because expected value of the mark is just doing the coding here, so to speak. So it's going to be 5 times expected value of x. So we can use this equation here, minus 25. Similar to coding, right? The way you find the different variable from the coding equation there. So they would just be 5 times 5 minus 25, which is 0 as required. Yeah, so see there already? Just going to add a page here, just in case. See, in order to pass the test, at least 30 marks are required. Okay, 30 marks are required. Find the probability that Sam will pass the test. So we need him to get more than 30 marks, okay? At least 30 marks, so that's, we want PM of at least 30 marks. But what is it in terms of x? Because it's easier to do in terms of x because we already know that x is a binomial. So the way to go with this is to substitute m in terms of x, right? Because m is 5, x minus 25, so I'm just gonna put everything in there and do it like this, right? Yeah, and rearranging that, so we get 25 moved the other side, we get 55, so it's going to be 5x here greater than 55, so x greater than 11 there. I'm just going to do that already. We just find the probability of that binomial of x being greater or equal 11, and that is simply 1 minus x less than or equal 10, right? Because discrete, you're gonna have to differ by 1 when you do the opposite sign. So that is just by the table, right? X less than 10, but n 25, p is 0.2. So we're gonna go to the binomial somewhere. No, here, binomial. So n is 25, right? N 25. Okay, and probability is 0.2. I'm just being careful here. All right, probability 0.2, and we need x less than 10, so that is the value there, okay, right? Agreed? So I'm just writing down here 0.9944, and 1 minus 0.9944 gives me 0.0056, right? Okay, go back to the question. So that will be the probability that Sam will pass the test. Well done. Okay, and not very impressive there. Past records show that when the test is done properly, the probability that the student answers the first question correctly is 0.5. The first question, only the first question, right? Note that. A random sample of 50 students, sorry, that did the test properly was taken, given that the probability that more than n, but okay, so this is D now, yeah. Okay. "50 students that did the test properly was taken, given that the probability that more than n but at most 30 students, so more than n but at least 30 students, so that's going to be more than n but at most, sorry, so at most is less than or equal 30. Answered the first question correctly was that. Okay, so this is basically P, but you see more than n, so we got to go less than that by 1, right? So that's going to be n minus 1 there to the left. So we need this probability. But before we do that, we got to think about the distribution. And this is, again, I think, Poisson, sorry, binomial. So we do x binomial here, n being 50, and the probability is 0.5, right? Yeah? So that's just it, I think. Yeah? So we need to split that into two terms. So that would be probability of x less than equal 30 minus the probability, this has to be an equal sign, sorry. Okay, so we need to include the n minus 1 here because that will be where we go from n to n minus 1, so it must include this. So we cannot subtract this out. We gotta go one less. That would be n minus 2. Because we can't subtract the n minus 1 out. We gotta keep it in the probability inequality there. All right, and this is given to be what? This whole thing, sorry. This whole thing is given to be, let me shrink that down a little bit, see if I can. Yeah. Okay, this whole thing is given to be 0.9328, right? So, yeah. Okay, so we can find this one and solve the equation there. So this one, p less than or equal 30. Okay, where n is equal to 50. I'm not sure if we did. Yeah, we do have 50. 50 and 0.5. So less than 30. That's 30 there. That's quite high. So I'm going to plug that in. 0.9405. So p being 50 and 30 being the, yeah, being the x. Okay, minus, I'm going to just keep that. So let's get back to the question there. Equals 0.9328. So making that probability the subject, we have 0.9405 minus 0.9328, right? Is that? No. 0.9328, yeah? Just checking here, being thorough, 0.0077. Now we want to solve for n, right? So essentially what this is we need to use the table. Yeah? Just by using the table. But note that n is 50 and p is 0.5. So we want to find something that has about that probability. I just spot this. So n being 50, sorry, n being 50 again. Now x is less than 16. You have the exact same probability there where the probability is the same column here. So we can write, because I found that x less than, what is that, 16 is exactly that from the table. That means we can match n minus 2 equals 16 and n would be equal to 18. Yeah, so that would be the answer there. Let's skip to number 3. We gotta make some more time here because I use a lot of time. I spend a lot of time on the first question. I need to make more time here. Okay. During Monday afternoons, customers are known to enter a certain shop at a mean rate of that. Now, mean rate, kind of Poisson maybe, suggests a suitable distribution to model the number of customers that enter this shop in a 10-minute interval on Monday afternoon. Yeah? Suggests a suitable approximation. Of course, this is Poisson distribution. But normally, writing only that is maybe not enough. So we gotta do x binomial, modeled as Poisson and we got to suggest the lambda value. Here is the every 10 minutes, so the 10-minute interval would have the same lambda being 7 there. Okay? Alright, so that's A done. B, state 2 assumptions. This is another important one. Necessary for this distribution to be suitable. Okay, so 2 assumptions is that the customers entering this shop are independent, right? So customers entering the shop are independent. Well, in reality, that means like if customer A enters the shop first, maybe the next customer will also be as likely as the customer A entering the shop. It's like they're independent. It's not like, oh, there's too many customers there in the shop. Maybe the next customers are more reluctant to enter or something. No, it's not like that. They're all independent. All right. So that's the first thing. And because this is already talking about the constant rate, so we can't really say constant rate of occurrence, because remember in Poisson there are 3 assumptions, like 3 criteria, so that you can model something as Poisson distribution. The constant rate of occurrence, the independent events here, but we got to put in context when we answer. And the third one is each event that happens will occur singly in space and time. Well, normally in time. Like no 2 customers enter the shop at the same time. We can write something like that, right? No more than, in this case, 1, yeah, customer enters the shop at the same time. My handwriting is so bad there, guys. But I hope the marker can read that, which is me actually. Okay, so those are the 2 assumptions that I would give. Okay, now next, C, a new shop manager wants to find out if the rate of customers has changed since they took over. Write down the suitable null and alternative hypotheses that the shop manager should use. So if we want to find if the rate has changed, this is not increase nor decrease, so that should be just not equal. That means the null hypothesis would be just lambda, because this is Poisson, just equal to 7, because 7 every 10 minutes. But the null hypothesis would just be lambda not equal 7, because the manager only believes that it's not equal to that, or has changed. That's the keyword, has changed. So has changed, it could be either increase or decrease, right? Okay, that's done for C, actually. Okay, so D, the shop manager decides to monitor the number of customers entering the shop in a randomly 10-minute interval next Monday afternoon. Use 3% level of significance. That's weird. Okay. Find a critical region to test whether the rate of customers has changed. Okay, so this is 2 tail. So that means we got to do 1.5 each tail, right? Okay. So, yeah, the same 10-minute interval. Yeah, so it's like, look, I'm drawing a bell curve here, but that doesn't mean we're using bell curve, right? That doesn't mean we're using normal distribution. It's just that we can illustrate that the critical region would be the leftward part of the tail and the rightward part of the tail. Okay? And we want 1.5% here and 1.5% here, roughly, for the critical region. Okay? Now, that because we know, right, how to calculate the probability of each tail. So you want the probability of less than this value and this value. So we must seek the probability of x less than or equal x1. It has to be less than 1.5%. And the probability of x greater than x2 has to be greater than 1.5%. Okay? So that means probability, if we derive from x2, that x less than x2 minus 1 would have to be less than, that would be what, 98.5%, right? Okay, so we are focusing on these two parts, this part and this part, because it's two-tailed. So there you go. This is lambda being 7, all right? I'm just going to go to Poisson, lambda being 7. Okay, 7 here. So we got to search for the value, but lambda being 7. So that is 0.0073 is, if you multiply that by 100, it's going to be 0.7%. If you go a little bit above, it's going to be over 1.5% already to the left end, right? So that means we got to write somewhere here that p of x less than equal 1 equals 0.0073, but p of x less than equal 2 equals 0.0296. So this is greater than the critical percentage here, the significant level. So we should use that value instead, that one. All right, we're gonna take that one for the left end. Yeah, and then we also look at the right end, right? The right end here, we need the one less than 98.5. So let's see, the one less than 98.5, this one is already over, so we're gonna write this one as being x less than 12 equals 0.9730, x less than equal 13 being 0.9875. Okay, so 13 would not be okay because it's greater than this. We want less than 98.5. So we're going to take this one. But be careful. This one matches that one. It means that when you write the critical value, okay, so the critical region, okay, that one can be taken directly because we don't need to flip the sign, so that's fine. So x less than 1, or the other one here, because this percentage is less than 98.5%, yeah, but we got to take the x2, actually we got to flip to the other side, so you got to add this by 1. So when you found the probability that satisfies your critical region significant level, you got to flip this number and add by 1. So the other part would be x greater than 13. Because when we flip to the other part, that has to be greater than 1 from the other side. So this will be my answer here, right? Critical region. Yeah? Just going to go ahead and do the next question. All right. Let me add a page first. Oh no, I can't seem to add a page somehow. Okay, let me just do something there. Maybe I need to delete these. Okay, I can now. Technical problem. Now question E. Find the actual significance level of this test based on your critical region in part D. So yeah, we just add up 0.0073 plus the greater than 13. So yeah, we do 1 minus this, guys. Okay, so 1 minus this to find the other side, because if you take this, it's not going to be right. Yeah. Okay, and calculator, 0.0073 plus 1 minus in the brackets there, 0.7973. Is it 0? Yeah, it is 30 there. Just being careful there. So that is the actual. Interesting. Okay, right. Interesting, which is it's a bit greater than the 3% level of significance there, but I'm just going to take my chances there, all right? During a random 10-minute interval that Monday afternoon, 12 customers entered the shop. Comment on this finding using the critical region All right. So 12 customers seem to be greater than the mean in a 10-minute interval. So it seems to be not in the critical region. So 12 is less than 13. Therefore, this not lie in the critical region. So not sufficient evidence to reject null hypothesis. I'm just going to write H naught there. Okay. And that means so the shop manager who believes that the mean rate of customer entering the shop might change, right? So we say that not enough evidence to suggest that the rate, I'm just going to take the wording here because this is the only word that seems to be the alternative hypothesis there, which is that the rate customer has changed. Yeah, that the rate of customers entering the shop has changed. Writing in a device is a bit more difficult. Okay, so that would be that question done. Number 4, right? Now we're number 4. We're more than halfway. The time is still good, I hope. Is it? 40 minutes, yeah. That means we have another 40 minutes. Okay, no, 50 minutes. The continuous random variable x is uniformly distributed over the interval a to b, given that px greater than 27. Continuous random, okay. Okay, so normally continuous random, we can draw a little graph here just to, so a to b, right? And we have a straight line here like this, yeah. Okay. So this would be 1 over b minus a, right? It's going to be the same for the entire interval. And 27 is somewhere, because greater than 27 is like 3/4. So you are looking at around here because the area to the right of that, towards the right end, is going to be 3/4. So it only makes sense when it's more than half like that. And this is 27, right? Okay. So we can just find the area proportion of this, yeah, and equate it to 3 over 4. So it's basically like finding the fraction of the area compared to the entire box here, if you like. So that's going to be b minus 27, is just this width here, divided by b minus a. Yeah, just the proportion of the length over the entire length, right? And that's going to be equal to 3 over 7. So we are getting an equation of b in terms of a, maybe. So I'm just going to do cross multiply here, guys. Very easy tactic there, easy technique to just simplify the algebra. So 4 multiplying the left part, 4b minus 4 multiplied 27 would be 108, right? Yeah, equals b minus a multiplying up there, I get 3b minus 3a. So simplifying, b moved to the left, I get b as a subject. 108 moved to the right, I get minus 3a plus 108. That's the first equation. We need to find another one because we are given that the variance is 300. And I think we get the formula of the variance because, yeah, uniform distribution here, the variance is that formula. All right, so we're going to use that 1 over 12. b minus a squared, we put it equal to 300. All right. So if we maybe substitute b in terms of a in there, let me move 12 to the other side. So, and while substituting b in terms of a, so I get minus 3a plus 108 minus a in the bracket squared equals. 12 times 3 is 36 and add 2 zeros. Yeah, just 12 times 300 there. Okay, so this is minus 4a plus 108 squared. I'm going to need to multiply the number big because my calculator is not capable of solving quadratically. So we have 4 there. If I take minus 4 out, I'm going to get a here minus 428, 47, 28, yeah. But because this whole thing is squared, so we got to be careful. That means minus 4 has to be squared before I can move it to the other side. I'm just going to do that. So I'm going to do 3600 divided by 16. Okay, so I get 225 here just to cut out a lot of numbers. And here, well, yeah, we can solve that using complete square there. If we square both sides, we're going to get plus or minus square root 225, right? Okay, which is plus or minus 15. Square root 225 is 15, yeah? And that would mean that a would be equal to, if you undo the minus 7 there, we're going to have, sorry, 27 plus or minus 15. Okay, so we can have a equals, that would be 42 or 12. Now, does it make sense? If a is 42, right, that's not possible because 27 would be out of the range, out of the interval. So a must be something less than 27. So we're going to reject that. So, and we conclude that a is therefore 12. That means b is equal to, substituting in maybe this one. So if a is 12, so that would be 108 minus 12. Sorry, 36, because you got to times 3 first there. So b would be 72. All right. Yeah, 64, 45. I'm just checking. Yeah, I think I'm happy with that. B is 72. I'm just checking. Yeah. Okay, so that's A and B done. B, find the value of K. Okay, so we have 4 times the probability of that equals that, right? Okay. You gotta visualize this one first, right? Because you have two sides of the probability there, right? So this is what was it again? Probability, yeah, of course, or probability density function. Okay. So 4 times that equals the other one. It means that the other one is bigger, right? I'm talking that this right part here must be bigger than this, right? But if we take that box back here again, and we know already that a, which is the lower bound being 12 and upper bound being 72. So yeah, so k minus 10 is somewhere. Let's say k is around here. So if k is around here, k minus 10 is around here. So let's do k minus 10 there. And maybe k here. And k plus 20 maybe would be further away like that. Okay? So this is just to visualize what we are finding, right? So the less than one would be this area right here, yeah? Yeah, so it's this part right here for the left part. And then the right part is x greater than k plus 20. So it would be to the upper bound there. Yeah, so actually maybe we got to move things around a little bit to fit the scale, but we don't need to do that. This is just to visualize. So this area here is a quarter of the other one, right? Just following that equation. So we're just going to find the area separately and plug into this equation. So 4 times, so the area of the smaller part first, yeah, which is the left part here. It's going to be doing the fraction there. Yeah, we want the area, so, right. And this is, don't forget, 1 over, so in 72, 1 over 72 minus 12 is 1 over 60, right? Just following the formula of uniform distribution there. Yeah, because upper bound, lower bound are already found. So it's going to be the area, which is the height of the rectangle, multiplied the width. And the width is just k minus 10 and minus 12, yeah, would be equal to the greater one right here, yeah? So that would be 1 over 60 as well. Sorry, 60. What did I write there? And then that would be 72 minus k plus 20. And you got to put that in brackets. I have seen this mistake many times. Students don't put brackets like that, and they just make a sign error there. Now, we can, of course, cut out the 1 over 60 here, because we don't need to do math there. And this would be minus 20, right, altogether. So it would be 4k here, expanding in. 4 times minus 22 would be minus 88. On the right part, we have nothing to multiply in, so just 72. 72 minus 20, yeah, if you expand minus in here, we would get 52. And that would be minus k. All right. So rearranging to solve for k, we get that, and then that would be 140 on the other side, just moving the numbers there. Okay, I think I'm happy with that. So k would be equal to, I think I don't need a calculator for that, so 28, yeah? Just doing the math there, guys. That's the value of k. I, this is weird. So I must have, so this is I, right? So where's my I, and then where's part A? Yeah, this is part A, and this is part B, right? Yeah, so this is I. A piece of wire of length 42 is cut into 2 pieces at a random point. Aha. Each of the 2 pieces of the wire is bent to form an outline of a square. This question comes up quite a lot, yeah? So, yeah, so we get a smaller square and a larger square, okay? So if this is a wire of length 42, okay, so if it starts 0 from here and 42 from here, you can cut in any place, and we can use again the uniform distribution because any point have an equal probability of being cut, right? So we're going to do x modeled as uniform distribution. I'm just going to write correctly here, a to b, right? So a to b there. A to b, so we write 0 and 42, yeah? A to b. Okay. Okay. Find the probability that the side length of the larger square minus the side length of the smaller square will be greater than 2. So if x is, say, the side length, so if x is where we cut from 0, right? Let's say that is x. The smaller square, maybe this guy here, okay, would be x divided by 4 because you need to bend that to a square. Let's say some people can do that. Let's say a perfect square. A larger square would be what? If that is indeed a smaller square, right? A larger square would be, hang on. Okay. So that would be 42 minus x and divided by 4, all of them. Okay, that's not a perfect square, but sorry. Let me just read the question again. Right. So we want the larger square minus the side length of a smaller square will be greater than 2. So look, guys, be careful here. We have a mirror image because if you cut beyond half midpoint, you're going to get the same effect, right? So that means actually you are only caring about 0 to 21. Yeah? Only 0 to 21. So it's like multiplying each case by 2 because let's say cutting somewhere here, let's say 5, it's going to be cutting somewhere 5 from the right part as well. So it's probably easier to change this whole thing to just a half, right? Because we only care about the point we cut, and this is 21. So I could change that to a 21, yeah? That's just where we cut. Okay? But x here is still the same, so yeah. It's just we care about half of it, and that's gonna make the other part being greater. This is still the same. We got to take 42 because the total length is 42. Okay, so we want the probability of larger square, which is that guy, greater, minus the side length of the smaller square, x over 4, greater than 2. Yeah, we want that. So we need to derive that. Okay, so it's, if we merge the fraction there, it would be 42 minus 2x over 4 greater than 2, right? So if you rearrange the inequality there, derive the inequality, you have 42 minus 2x greater than 8, moving there. And if you make x the subjects, so I would have 42 minus 8 on the left, that would be 34 greater than 2x, right? Moving the 8 to the left. And if you look from the other side, right, dividing by 2 both sides, I have x less than 17. Yeah, we want to find x less than 17, right? That's the cut point in 21 there, all right? So this is finding the probability because we model it as a being 0, b being 21, so that would be 1 over 21 minus 0. That's just the formula here, yeah? Probability density function, the upper bound minus the lower bound. And then we're going to multiply that by the just the 7 until 0 here. Because it's like we are, again, guys, you have to be able to visualize. So this is a strip from 0 to 21, but we take 17 and less than it. Yeah, so it's like 7 to 0 divided by 21 to 0. Okay, so P of x less than 17 would be 17 over 21. That would be the answer there. All right, so I'm gonna jump to question 5 now. And this seems to be a continuous random variable. Okay. The continuous random variable x has a probability density function given by that. The cumulative distribution function of x is f capital X. Show that f capital X is that, right? For 1 to 2. Okay. So we're just going to have to integrate, yeah? So basically, this is the formula. You integrate from everything, the probability density function. But for this domain, this part of the segment, we're going to integrate that part being from 1 to 2 and that function there, because that's the specific part that they want. Okay, putting the domain, the bounds as 1 to 2 there, and you just integrate that. So this is basically pure math question. I can take 1 over 4 out because I don't want it in the integrand. And then integrating 3, I get 3x. Integrating minus x, I get minus x squared over 2. And then putting the bound in 1 to 2. Yeah. So that would be, again, guys, I would like to substitute the bounds for each term, not each set. So I'm doing 3, 2 minus 1 here, putting 2 and 1 together, doing minus in the brackets. And then 2 squared minus 1 squared over 2 together. That's done. It's easier to see. So, wait, hang on. What am I doing? Sorry, I need to put x here because they need the function. Sorry. So I have x here, and I got to do x here, and x here. All right. So x here, and x minus 1, and x squared minus 1 like that. All right. Yeah, just the same thing, but you just put x in. So expanding everything, simplifying the brackets, we get 3x minus 3 minus, so this is x squared over 2, minus minus, so it's a plus, 1 over 2, right? Just trying to get what they want there. So if we expand in, we keep 3x in the brackets and minus x squared over 2 in the brackets, and pushing the number out of the brackets. So the number that is to be pushed out of the brackets would be minus 3 plus 1 over 2, that is minus 5 over 2, right? Minus 5 over 2 multiplied 1 over 4 would be 5 over 8, which is as required. Yeah, so this is just the bound 1 less than equal x less than equal 2. Okay, just just in case they want us to write that. And this is part A. Part B, find f(x) for all the values of x, all right? Now, you gotta find, so okay, still, you have to integrate the next function, putting the bounds as 2 and x again. Yeah, but then you gotta add, right? You gotta add the value from the previous cumulative value. So because when you have cumulative distribution, the area gets added up consecutively, right? So if you only have this without adding another part, this area, and if you put 2 in the formula, it's going to give you 0. You can try that. If you ignore this part and try integrate, when you put 2 into your capital Fx function, you're going to get 0, which is not right. So it's got to account for the previous area, and we can find that by substituting 2 from the first equation here. So we're going to substitute 2 in here because 2 is the upper bound of this first function. Okay, so we're just going to do that. So this is the second part. That's going to be 1 over 4 and then x minus 2 here. Yeah, just substituting the bound in already, integrating. Yeah, and if you sub 2 in here, what do you get? 2 sub in there. 3 times 2 is 6. 2 to the 2 is 4, so over 2 is 2, and minus 5 over 8. So that's going to be cut to 1, so that's just minus 5 over 8. So if I'm expanding everything, I get 1 over 4x minus 8 minus 5 over 8. So that would be 1 over 4x minus 8 times 8 is 64. 64 minus 5 is 69, so 69 over 8, right? Let me check something real quick, guys, because I think I have a problem. Just 1 minute, yeah? I'm not looking at the mark scheme, of course. Okay. Yeah, so that would be my function right there for the, so fx equals that for the second bound. And then we do another part similarly. Okay, so another part would be integrating that dx from the bound 3 to 4, and we're going to add the area from the previous part again, right? So again, we're going to do f, the previous part upper bound is 3, so we're going to add f3 in there. Okay, do the integration there. We have that, and oh sorry, this should be an x, right? And then integrating x, we get x is 2 over 2. Integrating minus 2, we get minus 2x. X and 3 here, yeah? Okay. And so if you plug 3 into the previous formula here, so that would be, okay, so that would be 3 over 4, but the denominator got to be 8, so that would be 6 over 8. 6, I get a minus sign. Hang on, that's not possible, is it? That's weird now. Okay, this whole thing is weird, because I should get a plus, not a minus. Wait, so if I substitute 2 in here, what do I get again? 2, 6, that's 6 over 2 is 4. 4 cut 4 is 1, so that's 1 minus. Oh no, 1 over 4 times minus 2 is 1 over 2. Look at that, that's not good, that's a silly mistake. Yeah. So that instead would be minus a half minus 5 over 8 would be minus 9 over 8, right? Yeah, I'm happy with that. Okay, now 3 substituted in the right function here now. Wait, hang on, this is... Oh no, it's still not right. Sorry. has to be 1 minus that. So this is a plus 3 over 8, right? And yeah, I'm happy now. And if we do the math there, we get minus 1 over 8, yeah? All right. Okay, so this is, again, putting 3 in there, we get 3 over 4 minus 1 over 8 now. It's all right now. So that would be 6 over 8 minus 1 over 8. That's 5 over 8, right? Okay, just simplify that and we should get the answer. So I'm gonna sub x in there and, simplify everything. So 1 over 4 times x squared over 2 would be, wait, I need to hang on, I need to sub 3 first. All right, so this is 1 over 4 x squared over 2 minus 2x, and then sub 3 in. So that would be minus 9 over 2. And minus minus is a plus, so plus 6 there. Okay? So multiplying out, we get x squared over 8. There's only one x term here, so we can multiply in, so x over 2 there. And this is 12 minus 9 over 2, so 12 is 3. 12 minus 9 is 3. 3 over 2, so that will become 3 over 8 plus 5 over 8. So that would all become 1. Now hopefully if we substitute 4 in here, we should get a 1. Let's try that. So if we sub 4 in there, we would get 16 over 8 minus 4 over 2 plus 1. Is that 1? Yeah, 2 minus 2 is, yeah, we get 1. So we're lucky here that we got it right. That means if we write fully the fx, okay, we should do that. So for x less than 1 here, we get 0, okay? For x from 1 to 2, that would be that function there that they just want us to prove. And you got to write the range here as well. And then the next part is this, right? So 1 over x over 4 minus 1 over 8. Yeah, that's the next part. Which is, what is that? 2 less than x less than equal 3. And then the last part is this guy, yeah? And that is just 3 less than x less than equal 4. I mean, I'm just stunned a bit because I'm out of space. That should be a 1 here as well. And that is x greater than 4. Alrighty. So that is our cumulative distribution function. Okay, so part C now. That's B, right? Yeah. Find P of 1.2 less than x less than 3.1. Okay, so P of 1.2 less than x less than 3.1 would be equal to, well, look at the cumulative function here. So we're going to start from 1.2 to 2 first. So it's in that domain first. So we're going to do, so f of 2 minus f of 1.2 first. That's the first part, because we can't jump to the next one because it's not continuous, right? And then we're going to add, the next part would be 2 to 3. So that's entirely the whole range there. So we can do f3 minus f2 for that next part, yeah, 2 to 3. And then the other part is from 3 to 3.1, so we gotta do that. Okay? Yeah, so we gotta add all this up, selecting the right equation to substitute, the right formula from the right domain. But if you notice, we can simplify this first. So I'm gonna cancel that and that, because we can. It's a plus and a minus here. I'm gonna also cancel that with that. So we are only left with just 2 terms to do, right? You gotta take some observation. I mean, I didn't anticipate this, but I just observed, so I see that I can simplify. So in totality, it's just f 3.1 minus f 1.2. And f3.1, you just have to substitute to this one here. Yeah, to the last equation. Okay. And minus the one substituting by x equals 1 over 2. So 1 over 2 substitute in there. That's a messy equation there. Okay, so that's 1 over 4. I'm just going to take out the brackets here and put it here instead. So 3 times 1.2 is 3.6. And then minus 1.2 squared over 2. And then minus 5 over 8. So I do a plus 5 over 8 there, right? That should be right. So let's get the value there from the calculator. So 3.1 to the power of, 2 over, let me put my calculator here. Okay, over 8 minus 3.1 over 2 plus 1 minus 0.25, which is 1 over 4. 3.6 minus 1.2 squared over 2, and then close bracket plus 5 over 8. Yeah, so that is 0.55. Maybe I'll put the 3 decimal places. Yeah, that doesn't hurt. Okay, just gonna jump to the next question now because we may be running out of time. What are we at now? Hang on. Oh, an hour and 10 minutes. All right, so number 6. Two boxes A and B. Is this the last question? Is not, so we gotta hurry up. Two boxes A and B each contain a large number of coins. In box A, there are only one pence coins and 2 pence coins. Ratio of 1 to 2. Okay, it's 1 to 3. Okay, this is about coin problem. Only one coin is randomly selected from box A and 2 coins from box B. The random variable t represents the total of the values of the 3 coins, like adding all the money up from all the coins. Okay, so one coin from box A, so box A only have 1 pence and 2 pence, but box B only have 2 pence and 5 pence, right? So we got to think about the cases first. And by that I mean, what are the cases that you can add up all the money from each coin to B? So that will be the top part here, the value of a little t. Because we are doing a big T, right? So because we are doing the random variable t, so that will be the probability of big T equals small t. Okay? So we're just gonna find the cases first. Okay, what are the cases? So first coin being 1 pence. Yeah, hang on. Just 1 from A and 2 from B. Yeah. So 1 pence, 2 pence, 2 pence, 1 pence, 2 pence, 5 pence. And this can be also 1 pence, 2 pence, 5 pence, 2 pence, right? Okay. Yeah, that's okay. It's just kind of like tree diagrams. All right. And then I could also have 5 pence and 5 pence, right? That's it for the 1 pence. And then for the 2 pence being from box A is 2 pence. It's like the same now. So you're gonna get 2 pence and all that again. Yeah, all that set again. So it's 2 pence and then 2 pence, you know what? I'm just gonna copy. No, I shouldn't do that because I can't do that in the real exam condition. So I'm not gonna do that. I'm just gonna keep writing. So 2 pence, 2 pence, 5 pence, or 2 pence, 5 pence, 2 pence. Yeah? And lastly, 2 pence, 5 pence, 5 pence, right? That's it. So we're gonna add up the cases. So this will be what? This will be 5 pence. This will be 8 pence. This will be 11 pence. This will be 6 pence. This will be 9 pence. This will be 12 pence. So those are all the possible total money that you can get out of this distribution. And we're gonna just plug them in. So 5, yeah, being the value of t. 8, 11. Sorry, it must be 6 first. 6, 8, right? 11. Wait, 9 first. Sorry, you gotta order that. Yeah, 9 first. So 5, 6, 8, 9, 11, and 12. Yeah, we're a bit over there, but that's fine. Just cancel that out. Okay, and now next step is to find the probability of each of the case, right? Now, because it's given the ratio, we're given with the ratio from each box. Yeah, so let's say, for example, from box A, the probability of taking a 1 pence coin would be, a quarter, because that's 1 to 3, so a quarter, 25%, right? So this will be probability equals 0.25 times 2 pence, and 2 pence from box B. 2 pence being, okay, I'm just going to do the probability here first. So this is 0.25 to 0.75. This is 2 out of 7. That's tricky. It's 2 out of 7 here, and it's 5 out of 7 there. Wait, no, sorry. What am I doing? I should look at the probability ratio here. So that's 1 in 5, so that's 0.2 or 20%. And that is 0.8, right? 4 in 5. Okay, so this is 0.25 times 2 pence and 2 pence. So that is the first case. The second case here, we need to multiply by 2 and only consider one of them. So that will be 2 times the 1 pence from the box A is 0.25. 5 pence from box B is, or 2 pence, 0.2, and the other one is 0.8. Right? I'm gonna just put on in a calculator at once, so I'm just gonna do the numbers here first. So 1 pence from box A is 0.25. Both 5 pence from box B is 0.8 squared. This one, 2 pence from box A, 0.75. 2 pence both from box B is 0.2 squared. This one we have 2 cases. Let me do brackets here so that the examiner who marks the paper will not be confused, which is me, of course. So P here equals 2 times, again, 2 pence now is 0.75 times 0.2 and 0.8, yeah, because that is only from box B, and the last case is 0.75 from box A and 0.8 squared, because that's 5 pence 2 times. Okay, and then let's put in, so the 5 pence must be the top bit, so that's 0.25 times 0.2 squared. We get 0.01. 6 pence would be this guy right here. Yeah, so that would be 0.75 times 0.2 squared. That would be 0.03, right? Okay, so 8 pence would be this guy right here, yeah, second line, 2 times 0.25 times 0.2 times 0.8. And that would be 0.08. And 9 pence here, yeah, we have 2 times there, this guy right here. Let me just move a bit. So 2 times the 9 pence, 0.75 times 0.2 times 0.8. That is 0.24. And 12 pence, oh, we forgot 11. How can we? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. Yeah. Yeah, almost. 0.25 times, so we're doing 11 first, times 0.8 squared. That's 0.16. Then lastly, the 12 pence case, 0.75 times 0.8 squared. That's 0.32. So I'm gonna try add them up here, guys, because if we get it to 1, then we are good to go. Next, just to make sure that we didn't get them wrong. We did get them wrong, hang on. Some of them maybe. So this is 0.34 plus. Let me check all the numbers I put in again. Yeah, this is not adding up to 1. Something is wrong. Let me check. Right, something must be wrong. Okay, so I'm gonna try check everything again. So 0.1, this is 122, 125, 152, 155, 222, 225, 252, 255. That seems to be all the case. Okay, so 0.25 times 0.2 squared, 0.25 times 0.2 times 0.8 and 2 times 0. For the 11. Yeah, 11 is 0.25 times 0.8 squared. Yeah, that's fine. 222, 0.75 times 0.2 squared. 225, 2 times 0.75, both of that. Yeah, there must be something wrong with my calculation here. Let me check that. I must have put something wrong. Okay, that's the 5 pence done. The 6 pence, 0.75 times 0.2 squared. That's not wrong. The 8 pence, 2 times 0.25 times 0.2 times 0.8, 0.08. That's still okay. The 9 pence, 2 times 0.75 times 0.2 times 0.8, 0.24. Are we missing something here? Let me check the time. Oh no, we only have 10 minutes. We're in trouble, guys. Okay, let me just calm down and check. That's not, yeah, that should be fine. Okay, I'm gonna check the 11. So 0.25 times 0.8 squared. Wait. 1.6, yeah. The last case, 0.75 times 0.8. Oh, aha. There must be something wrong here. That's the 12 pence case. That's 0.48. Now this should all add up to 1 now because I feel like they do. There you go. Okay, quickly, yeah? Okay, we're still okay, I think. So, yeah, now B, right? The random variable m represents the median of the values of the 3 coins. Median, okay? Okay, another sampling distribution. We can't copy, that would be unfair. So I'm just going to do a table. That's fine. And we do a little m here and probability big M equals small m. Okay, so median, right? So what are the cases? This one median is 2, right? Probably 2 is the smallest median, so I'm going to put 2 here. And what about this one? Also 2. This one is also 2, same thing, just swapping the coins. This, is there any bigger than 2? Yeah, okay, we're going to write 2 here. This is the 2, right? This is also a 2. This is also a 2. Yeah, there are many 2. And then what is this? A 5, right? And then another one is a 5. This is also a 5, right? So only 2 and 5. Not to mention the scale of the table. So, and then, yeah. So we're going to add up the 8, the 5, the 8. Okay, let's do just the 5 because it's only 11 pence and 12 pence cases from above. So that would be 0.16 plus 0.48. That would be 0.64 here. Yeah, just these 2 cases, giving 5 for the median. And the other part is just adding all up the other parts is 0.36 there. Okay, so that's it. All right. Oh, but it's 4 marks. Okay, so I probably have to write something, guys, to show my methods. So P of M equals 5 would be, yeah, I'm just going to say from the 11 pence case, 0.16 plus 0.48 being equal to 0.64. So P of M equals 2 would be 1 minus 0.64 equals 0.36. All right. And that's my table right there to be the sampling distribution. Okay, guys, next question, last one. We got about less than 10 minutes. Let's see if I can make it. Okay, continuous random variable probability distribution again. Figure 1 shows the graph probability distribution. Fx consists of two straight lines, segment join, x equals 4 here in the middle, and 8. Show that a equals 1 over 16. All right, so, okay. If we find the area of this thing, we get 1, right? So, at x equals 4, yeah? So, fx would be equal to, if we substitute 4 in here, we get 4a. And that is indicating the height of this triangle. So the area of the triangle is 1/2 times 8 times 4a should be equal to 1 easily. So if we do the numbers here, we get 1 over 16 as required. That would be my just easy technique. Just look at the area. Hence find the value of b. All right, so the value of b here, well, we can integrate as well. So the area from the first part is already half, kind of, because this is symmetrical. So that means the area of the other part, which is, what is it, if we integrate this, or we, or we can do 4 substitute in the probability density function, which is, you can substitute it in the first part too. That should give you the same as this part, right? So if we sub 4 in the ax, we get 1 over 4, just 4 over 16 there, right? Because a is 1 over 16. And that should be equal to 4 substituted in the other function. So it's b times 4 plus c. Okay? So we have an equation here. We want to find the value of b. And the other part here is f. Substitute as 8, you got to get 0 here, yeah? So that would be b sub in x here plus c. Sorry, x is 8, not 0. Okay, so this is simultaneous, guys. Yeah, you can see that. All right, so just subtracting both equation here, we get 1 over 4 equals minus 4b, c goes away. So that means b is equal to minus 1 over 16, right? Yeah? Well, that makes sense. The gradient of the first part is 1 over 16. The gradient of the other part is minus. And then c would be equal to, substituting back. So 1 over 16 here, substitute in, we get minus 1 over 4. Add this, we get c of 1/2. That's b quickly, because I'm running out of time, guys. I guess you can excuse me on that. Okay, this again. Sorry, my app is just not behaving right now. Okay, so part C. We're still good, I think. Using algebraic integration to show that var x is 8 over 3. So we're going to do integration. So that's going to be x squared fx dx. Yeah. And that should go from minus infinity to infinity. This is e of x squared. And we got to minus the mean. Yeah, we got to minus the mean squared. And the mean is clearly 4, guys, because it's symmetrical. So I'm just going to take 4 squared there already. I got to be quick. So, okay, this will split into 2 parts, right? So we are integrating x squared. The first part is 1 over 16x, right? That's from the ax there. dx, we are integrating from 0 to 4. All right. And then plus the other part is from 4 to 8. X squared, and then we are doing b is minus 1 over 16x. And then c is plus 1 over 2. And then minus 4 squared. Right? Whatever we got there should be the variance of x as required. So we're going to prove that. So this is x cubed. We integrate x cubed. We get x to the 4 over 4. So that would be x to the 4 over 64. Substituting in the bounds. And then this is, if you expand the x to the 2 in there, you get x to the 3. Again, integrating, we get minus x to the 4 over 64 for that term. Expanding x to the 2 into 1/2, we get x to the 3, but integrating, x to the 2, integrating gives x to the 3 over 3, which is multiplying 2, we get 6. 4 to 8, and then minus 16 there. So this will be 4 to the 4 over 64. 0 goes away. That would be, okay, so I'm doing minus 8 to the 4 over 64 plus 8 to the 3 over 6. Minus minus becomes a plus. And then minus 4 over 3 over 6 minus 16. We got to do some simplification here, guys. Yeah, because my calculator again. Okay, let's see. So we're gonna, this is tricky. Okay, so we pair up this and then we do all the over 64. So that would be 4 to the 4. Yeah. Plus, no. Okay, marking the paper now. So this is the mark scheme for the S2 paper, October 2024. All right. I'm a bit excited because I did very bad, I think. Let's see. Because at least I lost 5 marks because I didn't finish the last one. Maybe I was talking too much, so I didn't have enough time to finish the whole thing. Let's see. Okay, so the first one, yeah. But anyway, okay, part D, yeah, I got that right. Ooh, they have different one here. I'll be harsh, right? So this is minus 4. Damn. Sorry, yeah, that's bad. Okay, Poisson distribution. This one is, yeah, the tail thing. Okay, so, yeah, I think I have these two. So the first method mark. Ooh, why is that? Hang on. Okay, I think this is saying x greater than 13 because they do 1 subtract my value here. Right? And then for 14, it should be there. Wait, but why did I get the different value there? Did I got the wrong value here? Wait, maybe I did. Hang on, let me check that. Okay, so you're looking at the formula sheet at lambda equals 7. Oh no, why? I copied the wrong number. That should have been 9872. It's a bad example here. Okay, so that should have been 72 there. If you do 1 minus this, it would have been exactly 0.0128. And this is going to be greater than or equal 14. Wait, yeah, I don't know why I chose this. Although it's not greater than... Oh yeah, man. My critical region here is also wrong. It should be greater than 14. So I lost 2 marks here. Yeah, I got this critical region, right? This should be less than 1. Yeah, this is, yeah. I believe this is less than 1. Because this is 2, right? So 2 is here. I got the first mark. So lost 2 marks there. That's bad. And this is a follow through because although I state the wrong value there, but it's a follow through because you see the word FT here. Yeah, so let's read that. FT award that or that, the sum of their 2 selected probability tails. Yeah, I'm gonna just assume that I get the mark here because I took this and then I put it here and then I add with this. Okay, so that's a follow through marks. Sometimes not allowed, sometimes is allowed. So you gotta check the mark scheme. I mean, if you can. Yeah, this part I ran out of time just about when I finished writing this. And then I was trying to figure out if this indeed gives 8 over 3, and it actually does give 8 over 3, but I didn't write the 8 over 3. So my working stops here actually. So this part cannot be considered and will not be. So I lost 1 mark there for the accuracy, just to say that var x is indeed 8 over 3, right? So I'm gonna, not give myself that mark. So I won't give myself that mark, all right? And I lost another 5 marks here because E, like D and E, right? 3 and 2 here, another 5, so that's in total -6. So how many marks did I lose? -6 there. I lost 12 marks, so that is just 63 over 75. That is just bad. So feedback on individual questions. Question 1 here was very tricky. It got quite a lot of my time just to think about the 30% here, guys. So I'm so sorry I took so long, and it was probably the reason why I didn't make it at the end. Like I didn't finish the last question. So it's like you don't use the whole Poisson. So the lambda needs to also be multiplied by 30%. Yeah, so the items found as liter, 4 items per square meter. So you need to multiply this 30% to the 4 items per square meter in order to get the right lambda for the face masks, right? So that is tricky, yeah. And I guess the approximation here is fine if you have the right lambda there, and it's a normal distribution, right? Normal approximation here. So this doesn't quite, in my teaching experience, I have never seen the case where you need to multiply the lambda by this kind of percentage. So this is also new to me actually. I've never seen that. Maybe I haven't done enough papers maybe, but I gotta admit that this is the first time I see a question like this where you have to multiply a percentage to the, let's say a total lambda of something to get just a fraction of lambda for other things within those things. So this is talking about a full lambda, a total lambda being everything you find, but 30% is face mask. I mean, it was quite hard to figure that out during the exam condition there, but I did, okay. And that cost me a lot of time. So this one, yeah, you gotta know, guys, that if one question is correct, so that means 1 in 5, so that's 20%. Yeah, this is important. And it's also important that when you let m be the number of marks, you have to know how to change that into an equation. So m needs to be in terms of x, right? Otherwise it would be quite hard here, because when you want to state the distribution of m, yeah, that has to be in terms of x, so that was fine, right? And then this is just the expected value, really, okay? So this one, the key thing here is probably after m. Maybe you get the first part, but maybe the next part might be tricky if you haven't seen a question like this. And now in order to pass, then if you got the earlier part, you got the distribution of m right, then you will just make it greater than 30 and find a probability, and that will be in terms of x because you already know the probability of x, so that was fine. This part here, yeah, I think I lost marks for this, right? Because I yeah, more than n, but at most 30, so I lost the mark because I put the wrong symbol for the inequality there, so I lost quite a lot of marks here because everything like just collapses, because I did n minus 1 and n minus 2 there. I didn't do n plus 1 and then Yeah, and then I got -4 there. Sorry, -3. So this one I got -3. So I lost 3 marks here. I was harsh on myself, so just to be fair and transparent. This one is fine. Is Poisson, right? And the 2 assumptions, yeah, just to also heads up for you here, because you can say anything. Occur at a constant rate of occurrence, occur singly in space and time, occur randomly, and then also independently, right? Those are the keywords there. This one I made a mistake because I didn't use 1.5% for the other tail, so I lost marks. So just to be careful, guys, when you look up tables, you can make mistakes. I look, instead of 5, I put 2 there somehow. Yeah, I wrote the wrong number, just one wrong digit there in the number. Yeah. So we comment on the finding, and then we conclude the hypothesis, if it's sufficient or not to reject the null hypothesis. So that was fine. This one was all fine, I think. It's just uniform distribution. So for this one, you need to probably visualize, right? You should try visualize the location of k minus 10 and k plus 20 in the uniform distribution diagram, right? And then the other parts are just easy, because if you make sense out of it first, what to calculate and what to get, and then you will get the value of k quite easily there. So maybe try visualize. If there is a graph for that statistical question, maybe use graphs, right? That will help. And this is a big deal, actually. Okay, this is a big deal because yeah, amazing that I got it right, actually. So when you cut something, and this is important, in S2, when there is a uniform distribution question, this comes up quite often from my experience. It's probably 4 or 5 papers that I've seen this kind of question. So it's like a cutting. It's cutting something, cutting a wire, cutting a wood, cutting a plank, cutting some kind of, you know, like a piece of strip, a strip of snack that children would eat, something. And then you cut, but you know, the context of the question might be, well, you cut it to do something else. But the key here is that if you cut, let's say the thing is 20 centimeters long, if you cut 1 centimeter from the left, it might give the same result as cutting 1 centimeter from the right. So that is why instead of considering uniform from 0 to 42, and we get mirror image effects, I reduce it to 0 to 21. So the distribution will be A is 0, B is 21. So it will go from 0 to 21 in the probability density function, in the graph, the top hat graph that you all know in distribution. But when you do something else to the cutting results, in this case, we cut x, and then the other part is 42 minus x, right? And then we got x and 42 minus x down to calculate the length per side of the square. It's just that the probability of cutting is considered from 0 to 21, right? Because it gives you the same result. Yeah. Why does it give you the same result? Because if you cut 5 centimeter from the left, it will be the same as cutting 5 centimeter from the right, right? Or you can multiply by 2, but it's like for any point you cut, there is a mirror effect on the other side. So you got to multiply that. You can also do from 0 to 42 and multiply by 2 on each side. Or you can do 0 to 21, right? So this is quite important here. I've seen it many times. So you got to do distribution in half, but the real effects. So here, as I mentioned again, I didn't do 21 minus x when I calculate the square there. So it's going to be x and then 42 minus x. The x will be divided by 4 to get the length per side of the small square. 42 minus x and then divided by 4 will be each side of the larger square. And then so on and so forth, right? After then you derive the math there, you get the probability of the larger side being greater than 2. Larger size minus smaller side being greater than 2. So, but you got to get the setup right for the uniform distribution here. That's the very key here. Because I think this is where people might lose marks, right? Okay, next. Question 5. Yeah, so this is fine. I got it all right. But yeah, the key thing about this here is just you got to be careful for each section here. This is called piecewise function. So whenever you see this, you got to be careful. But the key thing is that when you get the cumulative distribution function, the capital Fx, if you substitute the upper bound, let's say this is a capital Fx, right? And let's say that, again, we get all the function we want. So actually, I can bring that here. You need to know that if you substitute 2 upper bound for this one, in this function, it's going to be the same value as substituting 2 in this function. It has to be, because the capital Fx is a continuous function, where the PDF, this guy might not have to be, right? Doesn't have to be, doesn't always have to be. But the cumulative distribution, yes. Okay, and this, yeah, I made a blunder on this one. So I said that, yeah, I would do the cancellation, but actually it canceled at the very beginning. So whenever you see any range like this in the probability, you can use capital F 3.1 minus capital F 1.2. So you gotta pick the right bounds for 3.1, which is this bound, but it's just a function of the cumulative there, and 1.2 being in the right bound. Yeah, this one I got it fine, I think. So yeah, it took me a while to just correct the table there because it didn't make sense. It didn't add up to 1. So I gotta recheck the whole thing. Took me some time to do that. But yeah, you gotta get this right in terms of the ratio here, what it tells you. So a ratio can also tell you the probability. This is telling you the proportion of how much 1-pence coins you have and how many 2-pence coins you have, right? Yeah, and this is fine. This is just looking at the total value of the coin first, and then find a median from that. So if you just go back to the video again when I walk through it, then I think I explained it quite okay. So when I did the paper, so just maybe go back. The simple case is just you try to think of all the scenarios, list them down, and be careful. Systematically list them down. Don't just go random, right? So when you list down the cases in probabilities, try be systematic. So you go 1 and then 2, 2, and then 1 again, and then 2, 5. Try list them down in order, right? And then when you got to change the first one, you got to 2, and then go from the beginning of how you did it before, using the same pattern. I hope that makes sense. And that will make sure that you won't miss anything, right? And for this one, it's just finding the mean from the listed cases there. So that's fine. And then the last one, I didn't have time to finish the other part, but I'm going to explain it in here. So this one is fine. Just this one maybe is a good idea to just look at the shape first, because we can make a lot of sense out of the shape. This is a triangle, right? So it's a triangle. Maybe it's a better idea to think that, well, the left part and the right part should be similar in one way. In this case, at least the area is similar. So, and the maximum point here which is found by substituting 4 in, should be equal to from two functions. So that is maybe what people might be missing here. If they don't look at the graph, they might not know how to find B or C or something. Yeah, because they should know that if you sub C in here, Cx, Ca should be equal to sub C in this term. Yeah, because they are at the same point. And if you don't look at here, if you sub 8 in here, you should get 0 for the fx as well. So that's quite the key there. Bottom line is use the graph when you have it. This is usually true in almost all papers. If you have the diagram or the graph, try make use of it. Right? Almost all papers that I've taught, when they give you the graph, use it. Try make some sense from it, and it will be helpful. Right? Otherwise, they won't give it to you. I mean, maybe if they want you to actually plot, they will actually ask you to plot. If they think that this is already enough, maybe they won't give you the graph. Maybe not, but they do. So that's the implication. So guys, I hope along the way you have maybe collected some of my techniques, which I hope it might be useful for you. Don't forget to hit the subscribe button and don't forget to keep studying, guys. See you in the next video. Bye.